Welcome to section 12.1, and we're going over circles. So one thing to note, we are only going over circles. We're not going over any of the other ones in this section. Alright, so what is the equation of a circle? Now there are actually two different equations of the circle that you're going to see in this course. This first one is called center radius form, and it's kind of easy to remember because you can read off the center and then the radius from the equation. So what does it look like? Well, a circle with center. So if we have a center, remember, and it's a point, so the center of our circle is a point, we call it HK, and it has a radius, R, and the equation will look like this. X minus h squared plus y minus k squared equals r squared. And this is where r is greater than 0. There are some cases where r is either 0 or negative. We aren't looking at those cases in this course. We're just looking at where r is greater than 0. Okay, and there's a little more information in the book about this, but this is the main thing. So once again, that point comes from what's near the x, and the y value comes from what's near the y. You have to be careful though, because it's the opposite of whatever number is there. For example, if we had the equation x minus 2 squared plus y minus, or y plus 4 squared equals 4, what would the center be? Well, the center is going to be the opposite of these two values. So what is the opposite of negative 2, positive 2? So it would be my x value, and then what's the opposite of positive 4? Negative 4. Kind of interesting, but that is how the formula works. And then what would the radius be for this example? Well, the radius is equal to this number on the side, so we know that r squared must equal 4. So you have to be careful. It's the radius squared that is that number. So that means in order to find the number, we have to take the square root of both sides, and r equals plus or minus square root of 2 or 4, which is 2. But we only take the positive because radiuses can't be negative, so the radius would be positive 2. Okay, so that's just an example. Example 1. Determine the center and radius of the following circles, then graph each circle. So feel free to pause the video and try these out by yourself, and then check in with me in a second. Now the first one. Let's see. My center, and I'm going to notate it with a C, so please make sure to do that on your work as well. So the center is opposite of this value, opposite of this value. So let's see, that's going to be opposite of negative 5 is 5, opposite of positive 2 is negative 2. So my center is 5, negative 2. And then my radius squared is that. So r squared equals 25, which means to find my radius, I have to take the square root of both sides. R equals plus or minus the square root of 25, which is 5, which means my radius is 5. So we'll take r equals 5. So let's go ahead and graph that. I'm going to graph that in green. Easiest way to graph this is first graph your center. So it's going to be 5, negative 2. Positive 5, negative 2 up here. I'll notate it with a C for center. And then let's see. My radius is 5, which means there are different ways to graph this, but I like to do, I think you could say, the cardinal directions. So I have to go north, 5. So 1, 2, 3, 4, 5. That's 1 point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Easiest way to do it. And then I just try to circle in the rest of it. Your circle doesn't have to be perfect, but it should look like it at least was attempted to be a circle. For example, if you just filled in the corners like that, if you filled in the 4 points, that would not look like you're trying to make a circle. So once again, make sure the points are rounded out. Try your best to make it look like a circle. I know it's not going to be perfect. Okay, so that is the first one. Let me go ahead and label my center. And then let's go ahead with the next one. X squared plus y minus 1 squared equals 50. You know what's weird? There is nothing next to the x squared. There's no number. But I can be sneaky, like you have to be sometimes in math. I'm going to rewrite the x squared as x minus 0 squared. right? Because that hasn't changed my problem. I just put 0 into the equation. That doesn't change it at all. And then I'll just rewrite the rest of it. And now you can see the x value. And then that's my y value. So my center, opposite of the 0, that's just going to be 0. And then opposite of negative 1, 1. So my center is 0, 1. And then my radius squared is 50. Radius squared is 50. So to solve for that, take the square root of both sides. We get r equals plus or minus the square root of 50, which can simplify into, let's see. So that's going to be root 25 times root 2, so that r will equal plus or minus 5 root 2. Now, for my problem, now this is where you're just, it's a little tricky, but I'm going to say take r equals positive 5 root 2. That will be my answer, my exact answer. But for graphing, it's kind of hard to graph 5 root 2. So what I'm going to do is I'm going to approximate it. Please note, this is just for the graphing. For your answer, you're going to give the actual value. For approximating is when you do the graphing. How do we approximate? Well, let's say we know r equals root 50. What is root 50 in between? What perfect numbers? Let me see. I know that the square root of 49 is 7, right? Now what's the next perfect square number? Well, 8 squared is 81. No, sorry, 8 squared is 64. So the square root of 64 is 8. And the square root of 50, which is what we have, is in between these two. It's in between 49 and 64, which means the square root of 50 is in between 7 and 8. So I'm just going to approximate and say it's about 7.5. That's as much as you need to do for approximating in this course. So r is going to be about 7.5. Now if you actually check with your calculator for the square root of 50, it actually comes out to about 7.07, but you don't need to use your calculator for approximating. If you want to, you can, but that's just a way to approximate without a calculator. So once again, you just give the approximation when you're graphing. You do not use it as your final answer. So for graphing, let's see, my center is 0, 1. So that's going to be right about there, center 0, 1. And my radius is about 7, so a little more than 7. So let's go ahead and plot those in. 1, 2, 3, 4, 5, 6, 7 and a half. 1, 2, 3, and once again, note you're always starting from your center when you count out. 1, 2, 3, 4, 5, 6, 7 and a half. 1, 2, 3, 4, 5, 6, 7 and a half. And then one more. 1, 2, 3, 4, 5, 6, 7 and a half. Once again, does not need to be a perfect circle, but best attempt at making a circle is always appreciated. Alright, there we go. Now here's a quick question. Which points are on my circle? Is the item inside, is this in my circle or on my circle? The answer is no. These numbers that would be inside here are not on my circle. The only numbers that are actually considered on my circle and that satisfy my equation, so the only points that satisfy my equation are the points that are actually on the outside area. So all these points right here in red, those points would satisfy this equation. And then the points along here, outside here on this circle, would satisfy this equation. Okay, so it's not the items inside and it's not the center, it's the items along the circumference of the circle. So now let's take a look at the next equation of a circle, and this one's called the general form. So this is the easier way, I guess, sometimes that you could say, of identifying a circle. So we have real numbers. So for real numbers, C, D, and E, we have x squared plus y squared plus cx plus dy plus e equals 0. Now, this form is usually not considered that useful. Why? Well, because the other form is super useful because you can find the center and the radius super easily from it. In this one, it's harder to find the center and the radius. However, it does tell you which kind of an equation it is because you can tell that the x is squared and the y is squared. And the numbers in front of x and y are the same, in this case positive 1. So real quick note, this is when we're introducing that new equation. How do I know it's a circle? The x is squared, and this time the y is squared as well. If you recall, in quadratic equations, the y is not squared. But because the x and the y are squared, so both of them are squared, it's a circle. And, more importantly, they have the same number in the front, on the x and the y. Alright, so let's go ahead and take a look at example 2. Determine the center and radius of each circle. I don't know about you, but I really can't tell what the center and radius is, because this is not the right form. This is general form. The form I want it to be in, x minus h squared plus y minus k squared equals r squared, this is center radius form. These guys are not in center radius form. So the question is, how can I manipulate it to be in this form? Well, if you'll notice, this form is when you have a binomial for each of these values and they're squared, which means, if I was to expand this, it looks like this when I expand it. They have identical binomials. Do we know of a trick that creates identical binomials? We do. It comes from when we're working with quadratics. It comes from completing the square. Because if you recall, completing the square, the goal was, when we had our quadratic, let's say if we had x squared plus some sort of x, let's say 3x, our goal was to find that perfect number that we could add in, and then we could factor it into identical terms, and then finally write that as that identical term squared, and then take the square root. Alright, so let's go ahead and do that. We're going to do completing the square to make these two equations in the right format to find my center and radius. But before we do that, we're going to actually have to do completing the square twice. Why is that? Because we have to do it to the x value, and then we have to do it to the y value. Okay, so let's go ahead and group the x's and y's. Let's see, so x squared plus 4x, leave space for that number we're going to add in, plus y squared plus 6y, once again leave space for that number we're going to add in, and then we're going to subtract that 9 to the other side. Once again, remember, we always just put that number to the side. Okay, so one thing you have to note, our x squared and y squared values need to have only a positive 1 in front of them to do this. And they do. Awesome. Okay, so that's done. So let's go ahead and complete the square. I'll go ahead and do the scratch work on the side real quick. I'll have to erase it. So completing the square for the first one, we have 4. We'll divide it by 2, and then we'll square it. So that'll be 2 squared, which is 4. So that's the perfect number to add in. Careful, gotta add it to the other side as well. We have to balance the equation. Okay, let's go ahead and do the other one. Now we'll take the 6 from here, divide by 2, and square it. As usual, we always divide by 2, then square when we're completing the square. Then 6 divided by 2 is 3, so square that 3, and that will be 9. So 9 is the number we're adding in. We got to add it to both sides again. Remember, we're going to balance that equation. Okay, so when we do that, these perfect trinomials factor into x plus 2 times x plus 2. Bring down that plus. Y plus 3 equals, and then negative 9 plus 4 plus 9 is going to be 4. And now I can rewrite these, since these guys are identical, we can rewrite that as x plus 2 squared, plus rewrite these guys, because they're identical, as y plus 3 squared equals 4. And what do you know? What format is this in? This is in the center radius form, right here. Super awesome. So now I can just pull my center and radius out of this. My center is the opposite of those numbers, so center is going to be negative 2, negative 3, and my radius squared is going to be that number, which is 4. To find my radius, though, I got to square root both sides. And r is going to equal plus or minus the square root of 4, which is just going to equal plus or minus 2. And we'll go ahead and take r equals 2 for my radius. Because once again, radiuses should be positive. Okay, just one more problem. Let me just go ahead and erase a little bit to make room. Let's see, that was what? Plus 9 plus 4? Okay. So let's take a look at the next one. Once again, we're trying to find the center and radius, and at the moment, this is in the general form. It's not in the center radius form, so how do I get it in center radius form? Well, I want it to look like some binomial squared, which means we're going to go ahead and once again use completing the square. However, we can't do that yet. Why not? Any ideas? Well, if you recall, in order to do completing the square, you need to have a positive 1 in front of your squared value. And in this case, we have a 3 in front of both of them. So we'll have to go ahead and divide out by 3 to get rid of that 3, which means we have to divide everyone else by 3 as well, because this is an equation. So that'll be x squared plus y squared minus 4x minus 6y plus 4 equals 0. And oops, that shouldn't have been 6, that should have been 8y. Okay, and next thing, okay, so it's set up perfectly now. The x and the y have a positive 1 in front, so now let's set it up for completing the square. Gather the x's together, leave space for the perfect number. Gather the y's together, leave space for the perfect number, and then move that 4 over to the side. And let's go ahead and find those perfect numbers. Usually you do your scratch work on the side. I don't have as much room, so I'll leave it in the middle. So for the first one, negative 4, once again, you divide it by 2 and you square. So that'll be negative 2 squared, which is positive 4. So we'll add a 4 and then add a 4. Running out of room. Okay, and then the other scratch work. Once again, you usually do this on the side work. Let's see. Yeah, you usually don't do it in the problem solving. So we'll take that negative 8, divide by 2, and then square. So negative 8 divided by 2 is going to be negative 4. Squaring that, that's going to be 16, positive 16. So we'll add 16 to both sides. Okay. So as mentioned, the scratch work is important to show that, but just usually do that on the side of the work. All right, so these trinomials should be perfect trinomials. So we should be able to factor them into identical binomials. So negative 2 and negative 2 plus, and that's going to be y minus 4, y minus 4 equals, let's see, those cancel each other out, and we're left with 16. And then we have x minus 2 squared plus y minus 4 squared equals 16. So, can I determine what my center and my radius are? I can. My center is going to be the opposite of these numbers. How do I know that? Well, this is in center radius form. See that? We have the two binomials, and then they're squared. Awesome. And then my radius is out on the side. So my center is going to be the opposite of negative 2 and negative 2 and negative 4. Opposite of negative 2 is 2. Opposite of negative 4 is 4. So my center is 2, 4, and my radius squared is going to be that number, so 16. Square root both sides, and we get that r equals plus or minus the square root of 16, so r is going to equal plus or minus 4. And since we have a circle and our radius should be positive, we'll take r equals 4. Okay, that is it for circles. So main thing, remember, the awesome formula that is your friend is this one. If your circle is not given in that form, you want to get it into that form. How do you do that? By completing the square. Alrighty, that is it for this section. If you have any questions, feel free to drop by an office hour or send me an email about any of the questions on this lecture or on your homework.